Okay, derivatives of base b logarithms. Now, to get derivatives of base b logarithms, it's more a problem of logarithms and their properties than really the calculus of them. What is a logarithm base b of x? Well, if logarithm base b of x equals n, that means that the base b to the power of n is the argument x. B to the power of n equals x. So now we're going to take this expression and take the logarithm, any base, on both sides of the equation. That's logarithm base a, any number a, positive, not equal to 1, of b to the power of n equals logarithm base a of x. Just put in logarithm base a here. Now, some properties of logarithms. This n can multiply in front of the logarithm. So we have n logarithm base a of b equals logarithm base a of x. Now, because we want to leave n by itself, we're going to divide by logarithm base a of b on both sides of the equation. This yields n equals logarithm base a of x divided by logarithm base a of b. Okay, but n was logarithm base b of x. So this also equals logarithm base b of x. And in particular, if the value of a that we choose happens to be the number e, Euler's number, then we have logarithm base e of x over logarithm base e of n of b, which is, of course, the natural logarithm. Natural logarithm of x divided by natural logarithm of b. Notice there's no calculus here. So now we're going to get into the good part. What if we want the derivative of the natural logarithm base b, not the natural logarithm, the derivative of the logarithm base b of x. So we have derivative of logarithm base b of x is the derivative of this expression. Natural logarithm of x over natural logarithm of b. So we're going to get the derivative. ln of b is a constant. So we can rewrite it as 1 over ln of b times ln of x. Okay, no derivative yet. We know that the derivative of a constant times a function is the constant, this goes here, times the derivative of the function. So 1 over ln of b times the derivative with respect to x of ln of x. And the derivative, and this derivative is, of course, 1 over x. And then we just rewrite it with the x in front of the natural logarithm. This is so that it doesn't get confused with natural logarithm of bx, but rather x natural logarithm of b. So this is the derivative. Alright, let's move on. What if we have logarithm base 6 of cosine and we want the derivative? Why is this? So, first we're going to transform it into natural logarithms. Just as we just saw, this is the natural logarithm of the cosine divided by the natural logarithm of the base, which is 6. Instead of writing divided directly under this logarithm, I'm writing 1 over ln of 6. Then the derivative is the constant, ln of 6, 1 over ln of 6, times the derivative of natural logarithm of cosine, which is, of course, 1 over cosine of x, times the derivative of cosine of x, which is negative sine of x. We always apply the chain rule. Okay, This negative can go in front. I got it right here. 1 over a natural logarithm of 6 and sine over cosine, which we can rewrite as a single fraction, negative. Here we just have sine, and here we have cosine of x, natural logarithm of 6. Of course, you can also, this is an answer, and it's correct. We can also say sine over cosine is tangent. So we can say negative tangent of x over natural logarithm of 6, which is also correct. Both are acceptable. Let's see this other one. F of t is logarithm base 2 of 8t to the 5th power. Again, transforming, it's more a problem of the properties of logarithms than the calculus part. Transforming this into natural logarithm, we have natural logarithm of the argument divided by natural logarithm of the base. And remember, this is a constant. There is no variable there. So, the derivative is the constant, 1 over ln of 2, times the derivative of the natural logarithm of 8t cubed, which is 1 over the argument 8t cubed, times the derivative of 8t, not cubed, to the 5th power, times the derivative of 8t to the 5th power, which is 40t to the 4th power. Now, in this expression we can cancel some things, like t to the 4th cancels with 4 of these 5t's, leaving only 1. And 40 and 8, this becomes a 1, this becomes a 5, and so we have 5 over t. And then just multiplying these two, we got that the derivative is 5 over t ln of 2. One last example. Now we have a product of logarithms. We have logarithm base 8 of x times logarithm base 4 of x. Well, no problem. Each we transform into natural logarithms. That is natural logarithm of x over natural logarithm of 8 times natural logarithm of x over natural logarithm of 4. Notice these two denominators are constants. So I can group them. 1 over these two, ln of 8, ln of 4. And here we have ln of x times ln of x, which is ln of x squared. The derivative then is the constant times the derivative of this part, which is a composition. We differentiate the outermost function, the square. So this brings down as 2 ln of x to the 1st power times the derivative of ln of x, which is 1 over x. And then we just need to rewrite the whole thing simplified. What's in the numerator? The 2 and the ln of x. So we have 2 ln of x. And in the denominator we have x and these two natural logarithms. X ln of 8 ln of 4. That's our answer.